Yeah, recording started. I'm audible, right? Can someone please confirm? Sharing.
Yes, you're audible.
Okay, cool. Sharing my screen. Okay. And okay. Yes, also. Cool. So today we are going to see about the logs. Okay. Mm, Logs available in the MySQL and also for the InnoDB engine. Um, so we will try to, I mean, uh, simulate all the logs for our better understanding. Okay. So before that, on the first day, we see about the acid property, right? So atomicity, consistency, isolation, and the durability, right? So there, the I stands for isolation, right? Isolation. So isolation means every transactions are isolated. They cannot interfere, right? They are completely isolated. At MySQL, as per the standard, their MySQL supports four isolation levels. Okay, so we need to understand that. So based on that, you can recommend the right isolation level for your application. And also, choosing the right isolation is very important. Okay, so for that, we need to understand the concepts around the isolation. So mostly the thing like this value for the isolation comes from the application team. This is something we cannot directly make this change. Okay, so this is kind of the change which should be coordinated with application front end and the backend team, and you need to choose the right one. Okay, because changing this parameter just in the backend may impact the application will behave differently. Okay, so this is quite important parameter. We should not take our own decision. This will impact the business. Okay, so understanding this four isolation level is very important. Okay, fine. So let's see about so the parameter name is transaction isolation. This is the parameter name. I think in the previous MySQL 5.7 tx underscore isolation. Later the parameter name is changed from tx underscore isolation to transaction underscore isolation. I'm not sure. I think MariaDB still we have tx underscore isolation. Okay. So anyhow, whether it is tx underscore isolation, otherwise transaction underscore isolation. Okay, so this parameter have four values based on the levels: read uncommitted, read committed, repeatable read. This is the default parameter, the default value in MySQL. And finally, it is serializable. Okay, so these are the four values we have for this parameter transaction underscore isolation. And to understand this better, we need to understand these three things: dirty reads, non-repeatable reads, and the phantom reads. This concept also we need to understand. Okay, fine. So let's see about this. Um, so where is my terminal? Okay. Mm, Let me put it here. Okay. So here, just logging one of the machine. MySQL is already installed, and this is the uh, version 8.0.44. Okay. No worries. This is the same concept we have in the 8.4 dot 7 everywhere. So far, there is nothing changed. Okay. So it should be fine. I was installing this uh, from the Ubuntu repo itself. So I get the default MySQL version, which is the 8.0 series. Okay. Now I am going to create one more screen below, and here also I am going to create one more screen. Okay. And everywhere I am logging the same machine. Isolation. Do so. And let me copy the same here as well. Okay. MySQL, and here also MySQL. Control L, show schemas. Everywhere I have the default database only. Okay. So the below screen I'm going to use for monitoring purpose, and the above two terminals I'm going to execute the commands. Okay. Then now let me quickly create database batch 5. Use batch 5. Okay. Create table T1, just like ID int primary key auto increment name worker 16. Okay, so it should be fine. Insert into T1 name values, right? A, B, C. Okay. Select star from T1. We have the three values. Okay, fine. Now let me check the current value. Select at transaction underscore isolation. The current value is repeatable read. That is the default one. Okay, repeatable read is the default one. Now, first, we can test one by one based on the, uh, I mean, the levels. Okay, so we should tell this in this way: read committed, repeatable read, and serializable. Because as you see, that one is changed. Read committed, you will see dirty read, non-repeatable read, phantom rows. Everything will be available, right? Everything can be detected. In the read committed, we dirty reads are not possible. Only these two are possible. In the repeatable read, phantom reads only possible. We are also skipping the non-repeatable reads. And finally, serializable, nothing. This is completely isolated. Okay. Serializable is completely isolated because it will serialize the transaction one by one. So uh, I mean, it will not allow the concurrent transaction. So this is completely isolated. So let's see one by one. So first of all, I'm going to make the change set global transaction isolation equal to read uncommitted. Read and read uncommitted. Okay. So whenever using making the change in the global, just reconnect and checking the value. Transaction isolation level is now read uncommitted. Okay. And just reconnecting here as well. Okay. Fine. Now let's do one thing. I'm going to start one transaction because MySQL is by default auto commit. So you don't need to define begin and commit or start transaction, end transaction. You don't need to define. So whenever you execute the SQL statement, it will be auto commit. Okay. To avoid the auto commit, if you want to do some testing or whatever, you want to create a set of SQL statements within the same transaction. To avoid the auto commit, you can just start your own transaction with begin or start transaction, whatever keyword you can use, and you can start the transaction. Okay, in that case, it will not be the auto commit. Okay, and now I am doing select star from T1. I'm just executing the select statement within the uh, transaction. This is not completed yet, right? This is not completed yet. In the other session, let's consider this is one of the user and this is the another user, two different session. Okay. Here also, I am creating one transaction and here I am doing update T1 set name equal to AA where id equal to 1. Okay, so okay, so database is not selected. 1 second. Use batch 5 and now I am doing begin and I am executing the update. Okay, so now I am executing the select again. Okay, so in the first session, the first user started one transaction. Okay, he executed the select, right? And then the second user or second session, we have started one transaction. We did one update. We did one update. But this transaction is not committed yet, right? This transaction is not committed yet. In the session 2, the transaction is not committed yet. Still, this user who is modifying something that is visible for the other user. Here you can see in the first select it was A, single A. Now in the second session, the other user is modifying something, but he did not committed it. He is just doing modification, but it is not committed it, right? Still before the commit, the other user can see the data. The user which what he is modifying that is visible to the other session before commit, right? That is the main thing here. He started, he begin, but he did not commit it, right? Still the other user can see the modification which is being done by the other user. Okay, so this is called the dirty read. So this is called the dirty read. Okay, and this is possible from the read uncommitted transaction. So when you set the transaction isolation level to read uncommitted in your database environment, what happened between the transactions, the user can see the data before they commit. That is something will not work, right? In the transactional environment, it should not work. So this is how it works. The first thing, dirty reads are possible, and here you can see this is the dirty read. Okay, fine. Now, whatever you can do, roll back or commit. Let me roll back. Okay. And after rollback, it is again singly. Okay, let me commit this. So at the end, there is nothing changed. Okay, so you got this point, right? This is how the read uncommitted work. The next one is read committed. Let's see how that will work. Okay. For that, first of all, I need to change set global read uncommitted to read committed. I am just reconnecting and checking the current value. Okay, so now this is changed to read committed and reconnecting the session here, reconnecting here as well. Okay, fine. Um, yeah. Okay, one second. Let me accept. Fine. Now let's see how the read committed work. Okay. So we updated the isolation value from read uncommitted to read committed. The same thing we are going to do. I am doing one begin and I am doing select start from T1. I can see this value. Now in the second session, I am doing the begin and the same update. I'm going to make the same update. Update T1 set name equal to double A where ID equal to 1. Okay. Now let's see. See, now this is not changed, right? This is not changed here. Now let me commit this. Let me commit. So after I commit the change, it is visible, right? It is visible here. So what in the so this is like this is not the dirty read. This is not the dirty read because the data is already committed, right? After the commit only, I am able to see that. Before the commit, I mean when the user, the other session or other user is modifying the data, it was not visible. So, but after he commit, it is visible here, right? So the in here, I mean, here we did overcome the dirty read thing, right? Overcome the dirty.
Sorry, sorry to interrupt. What do you mean earlier you told, right? In MySQL, without commit, it will automatically commit the data. Here, what does it mean? Here, why we are giving commit statement?
Yeah, yeah. So by default, MySQL will do the auto commit.
Auto commit. Then why you are giving commit?
Yeah, yeah. So that's what I'm telling. If you see by default, MySQL will do the auto commit. See here, if I'm
Yeah.
just doing the running the update statement, it will automatically
Mm,
commit, right? So we cannot explain the scenarios, right? So
mm.
to avoid the auto commit, what I'm doing is whenever you are doing begin or start transaction, whatever, it will overcome the
Oh,
auto commit.
auto. Okay, okay, got it.
Okay, we are
Sorry.
just
Yeah.
manually starting the yeah, yeah.
Transaction.
That you got it right.
Yeah, got it. Yeah, thank you.
Cool, 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 cool. One second. Let me mute for just 30 seconds. Give me 30 seconds, okay? Hey, sorry. Okay. Cool. So now you got the difference between the read uncommitted and read committed, right? So there we had the dirty read scenario, but here we avoid the dirty read, but still the thing is within the same transaction. Here this is actually these all the selects are executed within the same transaction. Within one begin, we did one select that given the identical result ABC, and then also it is ABC. But when someone committed the data from the different session, after that when I am executing this select, I can see the different data, right? I can see the different data. This is called the non-repeatable read. Okay. So in some environment, this may create the problem because when the transaction, let's see one real-time example. If you are booking some tickets or theater seats, okay, so initiated the transaction, so you are seeing some four seats, or let's say you are seeing once you start open that seat selection page, if it is showing 10, then that 10 sheets should be available for the entire transaction, right? So that you can make the proper booking, right? If it is changing the in between your transaction, then that is something not right, right. So it will confuse. You will not make the proper booking, right? So for some kind of scenarios, that within the same transaction, the data which we selected, that should be available until the transaction is completed. Okay, for the consistency purpose. But here with the read committed isolation level, you overcome the dirty reads. That scenario we already overcome, but still this non-repeatable read is possible. Non-repeatable read means within the same transaction you can see the different result for the same select statement. You are seeing the different result. Okay, so this is the non-repeatable read. Now the next level of isolation level, you can overcome that. Let's see that. I am just commit this, and I am now going to change the transaction isolation level from read committed to TABLE, repeatable read. Thing spelling. Okay. Let me do, yeah, reconnect everywhere. And let me copy this. Okay, so everywhere it is repeatable read. Okay, fine. Now let's do the same thing. Begin on the session 1. Doing the same thing, select star from T1. I can see this value A, B, C. Okay. Now in the other session, begin. Let's do the update now for B. Okay. Okay, let me admit 1 second. Now we are setting to B where ID equal to 2. Okay. Updated. And I'm checking the select statement here. It is not showing, right? B. Now let me commit this value. So in the previous read committed, after commit, I was able to see the change. But now, if you see, still it maintains B, C only, right? Here I already committed this value, begin, commit. I did this update, setting name equal to BB, where ID equal to 2, right? But if you see, the session is still showing the older value. If you see executing the select again, still it is showing the single value. Okay. Now let me make one insert here. Uh, let's do the begin insert into T1 values 2 column, right? 4 comma D 4 comma D. I enter and commit. I did the commit. And here if you see select star from T1, you have all the changes, everything. This is visible to this user. But let me execute here. Still, the value we did two modification. We did two this single B to double B, and also we made one insert. Okay, this also committed. Everything is committed in the session 2, but still the session 1 is keep maintaining the uh, same result. Okay, so this is due to the repeatable read. So how this repeatable read will work when within the transaction, when the first statement is getting executed, which means when this first select statement is getting executed, it will take the snapshot of this result. Okay, it will take the snapshot of this result, and it will maintain this until the transaction is getting completed. Okay, it will maintain this result until the transaction is getting completed. So here we avoided the dirty reads and non-repeatable read both. But in the repeatable read, still phantom rows are possible. Okay, let me show you how that can appear. Now within this same transaction, I am doing update T1 set name equal to dd where id equal to 4. Okay, if I'm doing this update, now if I'm executing this select statement, you can see this fourth row is now visible, right? Previously, in the other session, whatever I inserted data, I modified the id value to, even there is nothing changed. But here, after updating the row which is inserted by the other session, when I'm doing in the same session updated, then I'm doing the select star. I mean, when I'm searching the same row, now you can see this row is visible, right? So this is called the phantom rows, but this is mostly not possible because I mean, I can guarantee 99.9 percentage this is something not possible uh, because the recent data, MySQL will work on FIFO, right? First in, first out. So the recent modifications, it will not be visible in the other transaction. It is not the dependent. So your application code should be developed in that way only. Okay, so this is mostly not possible in the real-time scenario, but still this can occur. Okay, we need to aware of it. That's it. Okay, so this is called the phantom row. So first read uncommitted, whatever we are modifying in the other session before commit, it is visible to the other user. That is called the dirty reads. Then read committed, there dirty reads we avoided because once the user committed the change, then only it is visible to the other user, right? We avoided the dirty reads, but when it is committed, it is visible on the other user. So within the transaction, the select can produce the different results. So that is called the non-repeatable read. That is possible in the read committed. But the next one is repeatable read. There, what we see, even the changes committed by the other user, that is still not visible in the transaction in the session 1, because when you have the repeatable read isolation, the select statement which is get executing at first time, it will take the snapshot of that value and it will keep it until the entire transaction. It will give the same result. Okay, still phantom rows are possible, that we see this scenario. Okay, the row which is by inserted by the other session, if you are modifying that particular row in your same session 1, then after executing the select statement, you may see that value. Okay, this is called the phantom row, but this is something not going to possible. So that repeatable read is the safest isolation level, and that is the default one also in the MySQL. Repeatable read is the default isolation level. Okay, fine. Now the final one is serializable. Serializable, even we do not see this one. We do not see the Pantham rows, but serializable something not recommended because it will impact your concurrency. It will allow the sessions one by one. Serialize the sessions. Okay, you may get into the lot of locks. Okay, so let's see about the serializable. Oh man. Okay, fine. Use batch file, batch file. Set global repeatable read to serializable. Serializable. Okay, spelling is correct. Okay, it is serializable. Serializable. This is also serializable. Okay, so here begin, select star from T1. Okay, and here begin. Let me do an update. Update name equal to B, where ID equal to 2. So if you see, this update is not going to execute. It is waiting, right? In this session, if you show process list, see that your update statement is running, running for 13 seconds. Okay. Show process list is the command line. There you can monitor all the current connections, current queries which are running, everything you can monitor from here. Okay. And once I commit this, you can see this update is completed now. Because once I committed or roll back this transaction is completed. Then it will process the next transaction. Okay, so that it is completed. So this is how serializable work. It will never allow the transaction concurrent, I mean parallelly. Okay, so if it is allowed parallelly, then only you will see this kind of things, right? Dirty reads, non-repeatable reads, and phantom rows. These things are possible, right? But serializable will never allow the transactions to run in parallel. Okay, so it will do one by one, so that you will see lot of locks in your database environment when you are going with the serializable. But that is completely isolated. Each and every transactions are completely isolated from one to another. But you will be get into this kind of situation. You will see lot of logs. See, this is actually a simple update statement, right? The table just we have 4 rows, but see, this is taken 33.77 seconds due to the lock. Okay, so this is how the serializable work. Okay, so as it is not allowing the parallel transactions to execute in parallel, you will not see dirty reads, you will not see the non-repeatable reads, as well as what is it, phantom rows. All the threes are completely isolated. So this is about the isolation level. Okay, so you need to be aware of it. So when you are getting into this kind of situations, discussions, you need to explain the thing, and maybe you can give some suggestions what would be the better. And having repeatable read will also negatively impact in the performance wise, that we will see in the performance tuning session. Okay, that MVCC, because as I mentioned, right, it needs to um, hold the snapshot for the long time. So when your transaction is very big, then it will be the problem. With your history length will be increased when you have the repeatable readers uh, isolation level. Okay, So when you are setting repeatable read, you need to consider all these things. You need to uh, check the transaction size, all these things. Based on that, you need to decide. Okay, there are different factors included here. Fine. So this is about
So the default one is read committed, right?
no,
Isolation.
default is repeatable read.
Okay, but as per the standards, this one organization standards are different. Most applications use which one?
From my experience, most of the people are using repeatable read only.
Is it? Okay.
Yeah.
In our environment, we are using read committed.
Almost, see, that is obviously the read commit is the in all other databases. Actually, that is the standard one, standard method, right? The one whenever you commit, then it will display in other transaction,
Yeah,
right? The
that is
normal
correct.
read committed is the actually accurate one for industry standards, right?
Yeah, that is correct. But I would say
Mhm.
that is also depends on the application what you use, right?
Mhm. No, in this one, in my organization, almost all the okay, I'll find. Is
Yeah.
there any
So
application is using?
in the older version, before MySQL 8, I think from MySQL 8, repeatable read is the default one. I mean, in the previous versions like 5.7, 5.6, when
Mm,
people have the MySQL, they mostly
mhm,
rely on the default value that is read committed. That is fine. But when, I mean, recently after MySQL 8, the default one is repeatable read, right? So mostly people they did not don't want to change that value until that affects. So now mostly people are using repeatable read. I see from my experience. I'm telling.
okay.
Yeah, and some people's also
So
when
when
they
you
are
install this one MySQL, so it will by default you are saying that repeatable read is the by default option
default value,
MySQL
correct,
since
correct.
MySQL. Okay,
Since MySQL 8. Okay. And
fine.
also, yeah, some of the people they do the upgrade from 5.7 to 8. They still want to keep it the same transaction isolation level what they were used in the 5.7. That is read committed. So there are different thing. But recently after MySQL 8, I can see most of the people's they are relying on the repeatable read isolation because repeatable read you will get more another things also that is completely MVCC. These things are evolved in the repeatable read isolation that we will see in the later on the performance tuning session. So yeah, that is it.
Hi, Sri. In which scenario this repeatable rate is required really? Like whatever they want, same result they will see entire that session, right?
Yeah, entire transaction it will maintain the same result. Correct.
Like in real scenario, what kind of scenario this? Why they are they don't want means updated data?
Um, I mean, you are asking for any kind of real-time scenarios
Yes,
for
yeah.
repeatable read. So what I would say, let see, if you are selecting something on your application, any kind of application, uh, what to say, this ticket booking, order choosing, whatever. Uh, if if you are if you want to see something, let's say I enter to the simple example is I am booking for cinema tickets, okay, and I am
Okay.
into the seat selection and I can see some 50 seats available, okay. So when I am choosing them, it should be completely, I mean, I already choose something, but the seats which I choose that should be available until I complete the transaction, right? Until I pay the money to book it, right? In the meanwhile, if it is changed, then I think that is something not that may confused or Right, you got that right. Uh,
That means, like, if let's say two, three people are booking tickets in parallel time, first user is choosing this repeatable reads, and he can see like 12 seats are available, let's say. And
mhm.
another second user already means booked that ticket. That means first user cannot get that 12 seats, right?
No, I'm not exactly sure on that because this application logic also matter, right? So if I am selected something that should not visible when the other guy initiated the transaction, right? That is something they will handle in the application side.
Okay.
Yeah. But whatever I am seeing when I am enter into the transaction, whatever I am seeing, that should be available until I complete.
Enter that
Yeah,
for that
yeah.
reason, right?
Yeah, yeah. There should be some application rules also. That is the
Mhm.
yeah.
Okay.
Cool. Cool. So this is about this isolation level. Yeah, I also written one of the blog about it. I written while working at Percona, so I will share this blog also. Okay, so maybe you can go through it there. You will find all the comments and everything. I feel that would be helpful. Okay, fine. So let's start with the
Hello. Hello.
yeah. Hi. Hello. Okay. Fine. So let's start with the next topic, which is the logs. Okay. So we have different kind of logs in MySQL. So we will try to address one by one. So for this, I created some of this table. Let me execute this just for the quick thing. Control L. Okay. So let me insert this data as well. Okay. So select star from employees. Okay, so we have this 8 rows available on this command octave control L everywhere. Okay, so here use batch file. Okay, so we have this data available. Fine. So now we will see one by one. So first of all, we know this InnoDB. So mostly we are using the InnoDB engine in MySQL. So I read one blog sometimes before, I mean, before this Postgres boom, some 4 to 5 years before. So one of the blog that describes the I think some 60 to 70 percentage of data is stored in the InnoDB engine. Okay, but I'm not sure how true is that. But yeah, InnoDB is quite famous, right? In the MySQL environment, we are completely relying on the um, InnoDB engine only, right? Mostly 97, 98 percentage people are using the InnoDB engine. There are some other engines also. They are choosing them until when it is necessary. Okay, fine. So. Uh, this performance tuning parameters mostly that everything is related to the InnoDB. So when you are optimizing the your MySQL environment, you need to focus on the InnoDB engine. Okay, some people pronounce InnoDB. From initially I start communicate with InnoDB. I'm not sure which one is the right pronunciation. Okay, but yeah, so we will mostly we will see more about the InnoDB in our classes going forward. Okay, so the first thing is now we are yeah, actually we are entering into that engine. Okay, that logs. Then next maybe we will address the architecture parameters, all the parameters related to the InnoDB, the different structures of the InnoDB engine, different file system, everything will be addressed. Okay, fine. So currently, so we have one table which is employees. There we have There we have 8 records. Okay. So this is we are going to test it. Okay. Test our logs. Okay. So we have one of the main purpose of having InnoDB is InnoDB provides the row level locking, which means if I'm updating one row, that particular row only will be locked. Okay. That is also will be locked for the other write transaction. Other read transaction, it will allow to read the data. That we will see that. But if you are going with the MySum engine, MySum is not providing the row level locking. If you are going to update one single row on a table, it will lock the entire table. Okay, it will be doing the table level locking. Okay, so in that case, all the access fro- to the to that table will be waiting until that update statement completed, right? But InnoDB is not like that. Let's say if you have 1,000 rows, you are updating fifth row, the other user can update the 10th row, other user can update the 50th, 100. Concurrently, they can do that. InnoDB provides the row level locking, okay, not the table level locking. That is the first thing. Now, within this row level locking, um, yeah, and also one more thing. When I'm This is for the insert update deletes. It provides the row level locking. The another one is DDL execution. Let's say if I'm running on alter, uh, I'm modifying some index, adding some index or whatever. Uh, Now recently alters are much evolved. We have different algorithms. You may already have a copy algorithm is the traditional one. Now in place instant is also getting very developing much. We can quickly add the column within a second. Even if our table is 1 TB, within a second we can add the column, right? So these all are getting evolved, but in a traditional way, in the copy algorithm, still now modifying the increasing the varchar length, these operations are still heavy. You should perform that with the copy algorithm. Okay, so in this kind of situation, your table will be completely locked. If you are going with you have the different approach. Of course, PT online schema, change GHOs, you have the different approach, but just I'm speaking in the traditional way. If you are running on alter, then it will lock the entire table, right? It will not allow the other statements like insert update delete. It will never allow. Okay, with the traditional alter approach, I am speaking. So that time you will get the table level lock. Okay, so that is another kind of locking I am telling. So by default, InnoDB provide the row level locking, and when you are making some DDL, there is a possible to get the table level locking. And now backups are getting evolved, backup operation. So previously we did execute the flush table with read lock, so no other write operations are allowed until the backup is completed. But now we have different options, and we have the dedicated backup logs as well. Okay, so these all things are there. So this is the general thing. We have the row level locking by default for InnoDB, and when you are making some DDLs, you will get the table level lock, and you can manually lock the tables for the backup purpose. Whatever, you can manually lock the table and unlock it. And there is also the dedicated backup logs also now available to perform the backup without not without, maybe less amount of locking. You can perform the backups as well. So different types of locks are available. That's what I'm coming to say. Okay, now let's see one by one. The first one is the shared log. So to I have prepared everything in my test environment today. I mean, just 3 to 4 hours before I made all the commands, queries, everything. I'll tested this, so I have the commands here. Just we can copy and execute. Okay, and we will see what is that. So first one is the shared log. That is also called as S log. So this will allow the reads, block the writes. So let's see that. So let me admin enter the waiting room. Okay. Who is this admin man? Hacker?
Yeah, me only. I don't know this thing.
Okay, cool.
I'm trying to join from laptop.
No issues. Fine.
Yes.
Fine. So here begin. So we are actually manually pushing the lock. Okay, lock in share mode, and we are just locking the ID equal to 5. Only this row we are locking. Okay, in the session 1. Now let's see how it will impact the session 2. In the session 2, I am going to update the same value ID equal to 5. Okay, updating the same value on the session 2. Okay, if you see, I am unable to update because this lock is already acquired. The share lock is already acquired for the ID equal to 5. And you can monitor that in your show process list. You can see this update is happening. So you may have one question: how long this update will be waiting to access this row? Okay, so that is the one of the parameter which is InnoDB lock wait timeout. Okay, so this is the 50 seconds. This 50 is the value in seconds, which means whenever the transaction is waiting for the other transaction to access the row. This will only apply for the row level locking. Okay, because here the same thing is happening. This session 1 is locked the ID equal to 5, fifth row, and this update is currently trying to access the fifth row, but it is not able to do because the fifth row is already locked by the first session. So this update statement is waiting to access the fifth row, right? So how long it will wait? It will wait based on the InnoDB lockwait timeout value, which is 50 by default, 50 seconds. Okay, it will wait for 50 seconds, and once it reaches the 50 seconds, it will give the error like this: lockwait timeout exceeded. Try restarting the transaction. You need to restart the transaction. And I also see some people's whenever they see this kind of error in their application, they directly go and increase this value actually. DB lock wait timeout value from 50 to some 100 or 500,000. But that is actually not the solution here, right? Because raising this value, what it will do, it will just allow more room for this update statement. That's it, right? So in case if you are seeing this kind of issues, lockway timeout exceeded in your transaction, I would generally recommend to analyze which one is creating the problem, which transaction is creating the problem, which means here this is the one, right? This is the one creating the problem, but you can check this in your production system. While the issue is happening, you can get it from the show process list, or you have the different tables and queries, information schema, DB transaction table, and performance schema also give lot of tables there. I will share the query to check that. Using that, you can easily identify which table, which statement is blocking actually. Then you need to approach why it is blocking. So right, then you need to, mostly this kind of issues should be, until there is no any issue in the database, you need to reach out to our front end team, and you need to tell them why this is taking, this kind of issues mostly we need to address from the front end by changing the code, all these things. The developer, we can just share this information: which query is waiting, which query is blocking, and how long it is waiting, how frequent we are getting error. Sharing those information, we can directly fix in the application logic itself. Okay. Increasing this lockwait timeout is something not the recommended approach to address this kind of issue. This is just this second statement is waiting for accessing the ID equal to 5, fifth row. It is not available because this is already locked the, I mean, processing this ID equal to fifth row. So this transaction, this session is not able to access it and it is failing. That's it, right? So increasing the InnoDB lock wait timeout value is not recommended, and it may negatively impact as well, because let's see, currently one update is waiting. Let's say your maximum like 100 or 500 updates. Similarly, if they are waiting, started waiting because of the higher lock wait timeout value. Let's say you make it 1,000, and due to that multiple updates started to wait, it will increase your connections. You can directly reach your max connection value, right? Then it will not allow the further connection. It may create downtime, right? There are different things, right? So just increasing this value is not the recommended solution. That's what I'm just coming to say here. Okay, fine. So this is about the shared lock. Let me just commit this value. And the next one is exclusive. Okay, shared means allow reads, block the writes. Okay, and for exclusive lock, what it will do? It will block the read and block the writes. Okay, here we did not tested the reads, right? Let me do begin this one. So anyway, we tested this write statement. It was not allowed. Select star from employees where ID equal to 5. Yeah, so reads are working. Okay. Now let's see about the exclusive lock. Control L, Control L. Begin. Yeah, yeah, started the begin. Now to push the exclusive lock, we are just going to start one transaction. I'm just going to update the ID called fifth row only here. Okay. Set age equal to 40, where ID equal to 5. Why it is blocking? Yeah. So, oh man, I think we need to change the isolation level. 1 second. It is serializable, right? So, select added transaction isolation. Okay, set global transaction isolation equal to global read REPE ATABL. Okay, cool. I was surprised why it was begin. Okay. So now we are going to see about this exclusive lock. I'm just going to execute one update statement. Okay. So which means this will block both the read and write, right? So in the session 2, I'm going to perform the read operation. Use batch 5. See, this is not able to progress. And let me kill this and let me perform once update here. Update employees. Okay, 1 second. Employees set age equal to some kind of 50, where ID equal to 5. Yeah, anyway, it should not allow, right? We already see this example because this update is already holding this value ID equal to 5. So it will not be available for the other session until it committed. Okay. So once we committed, you can see it is available. After we committed, you can see this update is also completed. It is completed in 11.47 seconds. Fine, this is about describing the same like row level locking. But the difference we need to understand is shared lock allows the reads, it will block the writes, but here exclusive lock, it will block both the read and write statement. Then the next one is record lock. This is exactly the row level locking only. Okay, block the same record. For example, you can see from here. What is the time? Yeah, so better you can see here we are updating the employee set age equal to 28 where ID equal to 3. Okay, ID where ID equal to 3. And in the second session, in the session B, I am doing the same where ID equal to 3. What happened? It should wait, right? Because when this transaction is holding the lock, it should not allow this, right? So it should wait. This is the like a row lock, same behavior. Okay, if I am executing this, it should work because this is from the same table. I am accessing the another row, right? So for example, let me quickly show this. Begin updated ID equal to 3. Now let me execute the same update statement on the other session. It should wait, right? It should wait because ID equal to 3 is already getting accessed. Now let me change the ID equal to 4. It should complete, right? It is completed because this row ID equal to 4 row is not locked by any session. So it should complete, right? Fine. Now the next one is gap lock. So this is something like empty space between the value. Okay, so let me show this. For example, first let me execute the select star from employees. Okay, so these are all the values we have. I am starting one transaction and I am running this where age between 25 and 30. 25 and 30. Okay, so here you can see four rows are available between 25 and 30, 25, 27, 28, 29. So, okay, so these values are available. Now, uh, if in the second session, if I am doing, let me perform one insert into employees values. Oh, yeah, not 35, but values. Let me make it ID equal to 9, comma, some name, comma, age is 26, giving 26. If you see, I'm not able to execute this inset. This is the gap lock because if you see where age between 25 to 30, right? The query given is 25 to 30, so which means here already we have 25, 27, 28, 29. I was trying to insert 26 for the age, but what happened, the entire 25 to 30, the entire gap is locked here. So this is called the gap lock. Okay, so and also let me insert some different value. For example, instead of 26, let me make the uh another value kind of whatever 40. Okay, you can see I am able to insert. And also if I am doing inserting 10, okay, 10 is duplicate entry. 9 duplicate entry. Oh, sorry. Duplicate entry for the primary key. 9 already inserted, right? Yeah, I am able to make the insert. Before the gap, before and after the gap, I am managed to insert. But if I am trying to insert some data within this gap, then it is not allowing to insert that particular value, right? So this is called the gap lock. So this is also same behavior. It will wait until the 50 seconds based on the InnoDB lock wait timeout. Once it reaches the threshold, um, it will be error. It will be error out. We need to manually restart the transaction. Okay, and the next one is MDL lock. So which is the metadata lock, which this comes in the alter statement. For example, let's say I'm canceling this, and here also I'm just commit this thing, and I'm starting begin, and I'm just running one symbol select statement, right? Symbol select statement, and in the other session I'm going to run one alter for adding the column, adding the new column. Okay, see, when I'm running this alter is not able to proceed. And if you see the process list, you can see this alter table employees is waiting for the table metadata log, right? So alter, I mean, in case of any transactions already established, alter should wait until they are completed. Then only it will able to start the alter progress. Okay, so here there is a open transaction. This is called the open transaction. Okay, open transaction. And for the same table, employees table, we holded this row. So this alter is not able to proceed. So the solution is we need to kill this particular query ID that is not actually recommended and before checking with the uh, team, okay, your friend and team, and after committed you can see the alter is proceed. Okay, so this is simple scenario I was created to produce the um, uh, exact logs. Okay, you can just imagine this with your production environment, so it would be helpful for you. So yeah, so we just created this, and the next one is flex table with read lock. Okay, so this is the global lock. Let me show this. So this will also do not allow any writes. For example, this is manually we are imposing the locks. So previously when we do like when you want to stop the application, let's say you are doing some activity uh, and you want to stop the writes completely, there are different ways you can enable the read only mode, right? So that nothing writes will happen in your database. And also this is also one of the option. If you execute the flush tables with read lock, your tables will all your tables will be locked for the writes. You cannot perform any writes. Okay, for example, I just did this flush table with read lock here, and I am trying to execute one insert statement. See, this insert is waiting, and if you see the process list, waiting for global read lock, right? Previously, it was waiting for table metadata lock. When you see this global read lock, there should be some kind of flush tables with read lock. This is executed, and whenever you are executing the MySQL dump backup utility, you may get into these issues multiple times until if you are using the single transaction option, you may see this multiple time maybe. And to
Sri,
release this, yeah,
can't we find that this one, the transaction, in the show process list, the
uh,
flush tables with read lock?
yes,
No, see, is this the 156 transaction ID? Is this either this one? This is for insert, right? Insert into employees.
Yes, correct.
But where is this transaction? Flush tables with read lock.
No, it is
Uh,
not a transaction.
you mean
Well,
this?
just we are keeping
Okay,
the lock, right? It is not a transaction.
no, okay, leave it this one. Even if we go with the above statements,
Here?
see, not this one. Actually, the first screen.
Yeah.
So if we go up, there we run some commands, right?
I'm not sure
So
about.
to generate a log. Oh, those are not. See, for example, earlier you given one statement, right? Go up. Here, select from employees where age group between 25 and 30 for update.
Yeah.
So this is a one transaction, or what is this one?
This is actually transaction. We started with begin, right?
Yeah, so during that time, actually just this transaction ID can't be find in show process list.
Transaction ID means connection ID. In the show process
Connection.
list, you will see the connection ID only.
Ah, See, for example,
Yeah.
I'm doing some other transaction. Now we got that show process list. Insert into employees is waiting for some global read lock or
Yeah. Yeah.
some other table waiting for a table metadata lock or
Yes.
something. We got it right.
Yeah.
So what is the transaction ID of this waiting for table metadata lock or is between this group lock? Where we can find that transaction ID.
Okay. So you are asking
See,
how
for
to.
example, normally what we will do to continue this update statement or alter statement or insert statement, if
Hmm.
we kill this lock,
Yeah. Yeah.
automatically it will work, right?
Yeah. No.
So how do you use maybe okay? My question is, we can find out in some other way this transaction ID. What is, but is it not show in this one and the show process list?
Show process list. If the blocking transaction is already running, then it will definitely
Mm,
show in your process list. But the query is not running. Your transaction is opened. In that case, it
mm.
will not visible. You got
Okay,
that, right?
which are the queries are
Yeah,
running in the current process, then only it will show in the show process list.
Correct,
yeah,
correct.
generally ongoing transactions or waiting transactions we can see in show process list. Already
Okay.
executed transactions, already executed or committed transactions, it will not be visible.
Mhm.
Yeah, but you have the different way to find that by enabling the performance schema and the event table. There are few events table. I will get back
Okay.
on that
So
tomorrow, the proper flow. Okay, regarding
okay,
that.
that is one way, and the other way we can find out these logs in with the different query also, right?
Yes,
Currently,
yes,
any logs are there in the database. Okay, that logs we can from there I can find out.
yes,
But
correct.
here actually just only the okay, I got it.
Running query will be displayed, correct.
Only in progress. Okay, running queries are ongoing.
Okay.
Uh-huh.
So here, just to fix this, you can just unlock tables. So once that is done, this insert is completed.
Mm,
Okay, fine. So the another one is the backup log. This is actually it will allow the reads and writes, but only the statements which impact the backup will be blocked. Okay. For example, if I am doing this, I can still do some insert, update, whatever. It will be work. But when I'm doing the modifications, whenever I'm whatever doing alters or anything, that will be blocked. That will be waiting. Okay, it will not allow the DDL changes. It will allow them normal operations during the backup, but it will not allow the detail changes because your backup will be resulted in the inconsistent state, right? If it is allowed the DDLs. So DDLs will not be allowed. So here you can see this is different, waiting for the backup lock. And also to release this, unlock instance. After executing this, that will also release your alter is completed now. And finally, one more lock is the deadlock. So for deadlock, I created two more different tables. So deadlock means whenever two transactions hold the lock and mutually requesting for the lock to be granted. In that kind of scenario, deadlock will happen. So let's see that. And in this one, we will also see one more tool. Okay, so let me you create one more database, create database, deadlock, use deadlock, use deadlock, and I created two tables here, show tables. Yeah, and here also use deadlock reconnected. And now let me insert some data on both of this table. Select star from T1, T2. We have this values. Okay. Now let me explain this one. In the session 1, we were in the session 1 begin, and I am updating T1 set value current value plus 10. Okay. And where id equal to 1, I am modifying the value id equal to 1 on the T1 table. In the next session, I am begin, and here I am updating T2 table. Here we are updating T1 table. Okay. Here we are updating T2 table value plus 20 some value where id equal to 1. Okay. Now it is fine because in the T1 sorry, in the session 1 we started on transaction and we are updating the T1 table, and in the session 2 we started on transaction and we are updating the T2 table. Okay, until this is fine. Now again in the session 1 again in the session 1 I am executing one more update statement. Now in the session 1 itself I am updating T2 table, set value to something, and where id equal to 1. Okay. Now what happened if I am executing this command? This should wait, right? Because on the T2 table, id equal to 1 is already locked by this session, right? So now let me execute. See, it is now waiting because this id equal to 1 is already locked. That particular row is already locked by this session. And the next update statement is in the session 2, I am doing T1 set value 10 where id equal to 1 on the T1 table. T1 table, the same id. Now when I am start this update, it will trigger the deadlock, right? Because why it is triggering the deadlock? Here, this, see, if deadlock is not happened, then what happened? Let's see, here there is no deadlock concept. In this situation, what happened? This update will keep wait for this, and this update will keep wait for this. So this transaction will never end, right? Already we updated the id equal to 1 for T1 here, T2 id equal to 1 here. Now when we started this update to T2 same id equal to 1, this update started waiting to get this row access. Now, if deadlock is not there, when I'm starting this update, what happened? This update will wait for this row, right? So both the update will be waiting for each other. The second update statement here and there. So this transaction will never complete. It will complete when we have this InnoDB lockwait timeout reached. That is one scenario. But let's say if my InnoDB lockwait timeout is higher, very higher, then what happened? This two transaction will keep wait. There is no other further way to proceed, right? So to avoid this, when both the transactions are holding the log and also mutually requesting for the log, that kind of situation, both the transaction, there is no way to proceed further because both are already locked and requesting for the same row log access. In that situation, deadlock will be triggered. Okay, so this is how the this deadlock is getting triggered in the MySQL. So you got this situation, right? And also when you are frequently getting the deadlocks in your database environment, deadlock is something we cannot stop from the MySQL itself. To fix the deadlock, we need to reach the front end team again, and we need to check the query logic, and we need to suggest the proper logic to get avoid the deadlocks. So for that, you need to capture the complete deadlocks details so that they can work on it, right? So to capture the deadlock, you have different options. You can enable the InnoDB deadlock parameter, and it will be directly stored in the error log. There are few parameters. For example, show variables like net. So deadlock detect is on, right? And print all deadlock is off. So you can enable this. So it will start printing the deadlocks in your error log. Okay, that is one option. And from my point of view, the reliable way is using the PT deadlog logger. That is one of the Percona toolkit tool. You can use that. Let me show how it will work. So you can just do apt install Percona toolkit or yum install Percona toolkit or dnf install Percona toolkit, whatever. Okay, you can install, and once it is installed, you will get all the Percona related tool. There, one of the tool is pt deadlog logger. Okay, so when you started this, it will start capturing the deadlocks. You can just redirect this into some file. Okay, deadlock some file, and you can take it for your reference. For example, it will mm, 1 second. Yeah, it is already there, right? File.deadlock. So you will get into the file. And one more option is you can you can get all these deadlocks in your database. For example, show schemas, use deadlock. There you can, this is, yeah, now I come to browser. So this is actually for each and every Percona tool, they have the detailed documentation. That would be really helpful. Okay, you can go through it. For example, here you will just reading this document. Here you can see all the PT tools are available. You can just go through it. Okay, and here you might have this create table structure. Okay, so by creating this table in your database, you can directly log the all the deadlock details in your database itself. So I just creating this table here, right? Show tables. Yeah, now this deadlocks table is here. Now let me run the command pt deadlog logger. Instead of storing the file, uh, destination is capital D means database, which is the database name is, what is that? Deadlock. Deadlock and comma capital T, capital T or small t, which is table name. That is also deadlocks. Okay. Now, if you run this, here select star from deadlock dot deadlocks. You can see these informations are now available in your database itself. So it will give the clear picture like which is block, like which server this come, and which is the timestamp when this deadlock happens, what is the thread ID, right, transaction ID, and which user it was executed, and how much time these transactions were taken, host name, if there is any IP, it will be there. Database, against which database, deadlock database, table T2 and T1, and which column created the deadlock, that is the primary key. Yeah, we did based on the ID column, right? That is the primary key. Log type record, which is the row level locking, right? And finally, if you come to the query, you can see these are the queries, right? So here you can see this is the complete, like if you can export this into some CSV, or you can export into the Excel sheet, whatever. You can share it to the friend end, like a team, and you can start working on it by analyzing the logic. Okay, deadlock is something we cannot fix directly from the database. We cannot stop it, or we cannot like there is no direct fix from the database side for the deadlock. So we need to share as much as details possible to the application team, and we need to work with them to identifying and changing the query logic. So I found this PT deadlock logger utility is very much helpful on capturing the deadlocks. Okay, and also you can also capture in the error log, but that is something you need to grab the thing from the error log. You need to make it somewhere. But having in your table itself, you can directly export into the CSV or whatever. You can share with your team to work on it. Okay, so this is what we had here. Yeah, so this is about the thing today. What is
Eh,
the time?
Sri, actually, just earlier I asked the same question. This time again repeating. See, for example, someone executed a transaction and they left out, right?
Hmm.
So, how do we find that, and how do we kill their this one? Uh, See, for example, if without commit they left out like that.
Yeah, yeah, I understand. So you mean some open transaction
Yeah,
how to find out, right?
yeah.
Okay, so that is something you can get it from the InnoDB status. And there are few tables also. Let me show that.
Hmm. See, somebody executed some update statement instead of killing that statement. So
Hmm.
who didn't commit that the transaction, just if we and they left out like that. If we kill that, this update statement, it will finish it, right?
Yeah, yeah, that is correct.
Actually rolled back, right, automatically.
Sorry,
If they are left without a commit, they will roll back automatically. No need to kill.
it will roll back automatically.
Yes. That's the thing. It is auto commit actually. If they didn't
No,
commit,
no, the transaction level which we are talking here.
Generally, we can see in show process list or show InnoDB engine, like engine status. There only the waiting transactions or logged transactions will appear in the InnoDB status.
Oh, division. Okay.
So yeah, let me try to simulate.
Yeah, let's see here. Same that one. Take that age group.
So start at the begin. Yeah, and let me increase the InnoDB lock timeout a bit here to set global time equal to 500 second. We should reconnect here. No. Should reconnect here as well. Okay, so now begin doing update. Okay, and here also begin doing the update. For now, instead of 40, I'm doing 50. What happened? Oh, sorry. Use batch 5. Yeah, so now this update is waiting. If you see process list, you can see only this update is visible. I mean, which one is waiting. So your question
Waiting.
is how to identify this session
Correct.
and how to release this
That
update.
is transaction, right? That is transaction. So how to identify the
Yeah,
transaction?
yeah.
Yeah.
So here, let me now maximize the screen. So pager list, show engine, InnoDB status. So this is one way.
Mhm.
So here, let me come to the transactions purchase play. Here you can see this is activate in 39 seconds, right? Lockwood stacks.
No, even the transaction also, whatever the going, there should be some ID, right,
Is
for
there
the
in down?
transaction ID,
Like
right?
you can, is there in down, like little update statement?
Yeah, this is actually currently waiting, right?
Yeah.
Yes, waiting.
Transaction has been waiting 37 seconds for the log to be granted. And primary batch, it is the exclusive, and this is the transaction ID for the transaction. So this is one thing, and no pager use information schema. Show tables like InnoDB, InnoDB TRX. Select star from InnoDB TRX. So from this one also you can get it. So this is currently running, right?
Yeah.
And this is also the another transaction which is running. So there should be some waiting ID, right? Table in use, rows log, there foreign key, log structure modified. So this is actually waiting, but 1 second. Schema. So we have the combined query. Actually, I have
Yeah, I'm looking for such a.
there is lot of queries available in website also.
Okay.
Logs. Let me check this table. I have in my portal also. It is in my drive. Yeah. So engine lock ID. Which one is blocking? Granted. So can I quick? Okay, better we can search in Google also instead of getting into my drive.
Okay.
My
No,
SQL.
in Oracle, generally, if we this is locked by this transaction, so that will give the transaction ID also. So if we kill that other transaction, automatically this will
Yeah,
continue.
the same way in MySQL also, but there is some we
Mm.
need to join few tables. Okay, the you can get it from the InnoDB status, but apart from that, if you want to see some simplified output, we need to join few tables. Uh, I have the query in my drive, but now I am Like
So this one locks also just you can should have
you
a look
can
on
go through my video also.
it. Okay.
Troubleshooting MySQL open transaction in sleep state. So this will entirely cover the thing what you are asking. You will
Okay.
get
Okay.
all
No
the
problem. No
information.
problem. I'll look into it.
Yeah, but yeah, let's.
That.
It will be quick, man. We can just get it from the documentation and we can do that. Um, how to debug now? Yeah. If anyone have the query handy, you can share it in chat. Instruction. Let me see. Yeah, I think this is the. What is this? This is from the process list and information schema threads. Let's see how we can basically find them.
This is active transactions.
Uh, enable this counter. This is not the one.
I think completed ones, I think we cannot able to see, I guess.
There are a lot of
No.
queries, but
No. I mean to say here the completed what it completed. It is not a transaction is not completed, right? Whenever you make it end, then only it will complete the
yeah,
transaction, right?
yeah, I got your point.
Yeah, that transaction ID, if
Yeah,
we know
so
that one.
here you can see.
Okay.
So this is the same thing we got it from the InnoDB status, right? So this is currently in the lock wait, and currently this
Mm.
is in your this is the blocking ID.
Okay, then kill that one.
Yeah.
Automatically, it will the other one will automatically
Yeah.
stop.
Now let me minimize this.
Mm.
So now kill this unknown. Okay,
No,
so
generally
that
it
is
will update automatically. IDs are like
no, no,
it will
no.
update. You
Yeah. So MySQL thread ID is killed here,
oh, that
Mm.
ID. Okay, in the
right?
transaction.
And you can see this is completed.
Yeah, yeah. So here thread ID. Okay, okay. That is
Yeah.
thread. This is
Correct.
transaction. Transaction which is already completed. Thread is it is still in progress. So we kill the thread. Okay,
Yeah.
got it.
You need to kill the MySQL thread ID. Yes, correct.
Thread ID. Yeah, got it. Yeah, the difference now.
Yeah,
Earlier, yeah, guys were asking, right? It is already completed. Thread is still that is called thread. Thread is still it is in progress. Transaction is completed. So if you kill the thread, then automatically in other transaction. Okay.
yeah. Query got completed, but the transaction is
Ah,
still open.
yeah.
It is not.
Transaction means that is the thread ID. Okay.
Uh, yeah, that is correct. Yeah.
In
So,
MySQL point,
so
it
now
is a
if
thread.
you see, if I am executing any command here, you can see last connection
Hmm. Yeah, correct.
and it will reconnect with the different thread.
Different thread. Show schemas.
Okay.
Okay. Okay. Got it.
Surely
Yeah.
same information it will show in that engine status only also, right?
Uh,
Like
can
thread
you?
ID and this lock information,
Got
which
it.
lock was.
Yes. Sorry, actually, can you please repeat?
No, this lock and deadlock information we can see in that engine, show engine is InnoDB status also, right?
In
How
show
to
engine InnoDB status, you will see the latest detected deadlock only. But
running only, right?
yeah. But if you have multiple things, then you cannot track the history there. You know,
Yeah, that I have a doubt on this. Like for
yeah.
the tracking information about the log and deadlock, that we can write in error log also in the general logs.
Not the general log. Purpose of general log is it will record all the activity, what you are doing in the database. That's it. It will not print any kind of deadlock, nothing. But
Okay.
you can record all the deadlocks in your error log. I show two parameter, right? InnoDB detect deadlock, that is the one, and print all the deadlock. InnoDB print all the deadlocks. So if you enable the print all deadlocks value from off to on, then it will start printing the deadlocks information in your MySQL error log. You need to get it from the MySQL error log. That is something possible. And from the InnoDB status, you can see this is the latest detected deadlock. Only the last deadlock informations will be available in the InnoDB status. And the most reliable way is using the PT deadlock logger. Using that, you can capture everything in your table.
Okay, that means like if any log and deadlocks in past, like historical, if
Hmm.
we want to see like a 2 hours back logs and deadlock information, for that we have to enable like some parameters, right? Otherwise, this PT deadlock logger.
Yeah, so parameter of this one. These two parameters show variables like deadlock. Variables like deadlock. So these are the two parameter. By default, InnoDB deadlock detect is on, and print all deadlock parameter you should turn on this so that it will print all the deadlocks in your error log.
Okay, this is the like deadlock information. Like those exclusive log and that share log, gap log, those we cannot print, huh?
Those things you can get it from the tables like InnoDB underscore transaction table, data underscore logs in the performance schema table. Otherwise, you can, if you want to keep track of it, you can capture your InnoDB status for every 5 seconds or 10 seconds into some file if you
Okay.
want to do that.
For the historical data, we have to capture from InnoDB status.
Yeah, but they are not also storing the data, right? Information schema, those are views that will provide the current information only. It will not maintain any history of your uh,
Correct, correct.
transaction.
Yeah.
Yeah, but in the performance schema, there is a event history table. There you can get it. But that you need to aware of the transaction ID, all these things. Based on that, you can get it the statements which are executed on the specific thread ID. These informations you can get it.
Okay, from database DBA perspective, one question I'll ask. Okay, like let's say in midnight or any night time, no DBA was there.
Hmm.
Developer faced some issues, and next day they ask with DBA. Last night from 12 to 2 o'clock, we faced a lot of issues.
Hmm.
Uh, Transaction was not completed. It was waiting.
Hmm.
DBA, can you check what was happening in past like 12 to 2 a.m.?
Hmm.
What was running that time? Like in that scenario, how DBA will means justify what was
Yeah, so
running that time?
there are different options, right? Let's say if you have the proper monitoring system, you will get the alerts for your lock weights, all these things, deadlocks, lock weights, long running queries, everything you will get the alerts. So you can get to know something on that. And if you configure the PMM kind of dashboards, you can easily monitor what was spiked that time, whether it is log weight or slow queries, whatever. And you might enable the slow query log. There you can find all the slow query log queries based on your long query time. Maybe if those are the simple queries, then you may investigate why it was slow. Like the previously it was faster and they are simple queries only. But if they were taken long time that particular time, you can get all this information from your slow query log. There is also the log time option in your slow query log, so you can get to know whether it is due to the lock or not. And in the most monitored environment, what we do, we will capture the show process list and the InnoDB status output for every 10 seconds or 20-25 seconds. You can keep for the keep running that daily basics. We will sip that, and we will have some retention to keep the last 7 days or 10 days of data in case of anything to debug the problem. We can create some script to capture these data also. So there is lot of way to figure it out.
Okay, yeah, thank you. So, like from PMM also, we can monitor like runtime activities only, right?
PMM, by default, I think it will store 30 days of metrics, but you can increase the retention if you need to maintain
Oh,
the historical data. Yeah.
that means all the activities it will capture
Yeah,
by
yeah, that is
PMM.
right. Yes. The
So
role
these
is,
these kind of locks, deadlocks, those things also it will capture. Huh?
yeah, yeah, everything, every metrics you can get it from PMM.
Oh, good, good. Thank you.
Yeah. You can also set up the alerts in PMM. We will have one session.
Okay, okay. Thank you,
Yeah.
Sri.
Cool. So, anything else, guys? And
One
thing.
one more question, Sri. Like while showing means your session, I had one query like this regarding logs. Different logs was there, right? Backup logs, shared logs,
Yeah.
gap logs. Instead of checking from the session level process list, same thing it will print in log also. I think you already mentioned something that time, right? Whenever I ask only. Means it will not print in the log file, right? General log and
Log file means, yeah, yeah, general log, it will not. General log will just record your system activity. That's it. It will not have any kind of log related information.
in error log also it will not print out.
Uh, yes, error log, you can get the deadlog thing. Uh, and a slow query log, at least you can get some more information if the query is written in the slow query log. You can get whether it is due to the log or not. Some
Okay,
information.
why I am asking? Let's say two, three developers are there. They are doing their activities means independently,
Hmm.
and these logs are there. And if they ask with the DBA, oh something I am inserting or doing the DML activities, but it is not completing. DBA, can you please check what it is running in that situation?
Hmm.
From like how we can debug. We have
You
to
can check
the
with
same.
them. First of all, I will check with them the error, what they are getting, right?
Okay.
So if they are not able to complete, then they should have some log, right? It should database should reported something, right? So
Yes.
get the error based on that. You can start your investigation.
Okay.
Yeah, and also get something more about the queries which they are executing, and check the process list. Ask them to start the task and start monitoring our database and capture the queries from the process list and see if there is anything abnormal thing happening in database or not during they execute the task, and monitor your error log as well. Keep the slow query in tail in some terminal. Just keep monitor, and moreover get the error what they are getting, so that will give the hint to you to debug that problem.
Okay. Thank you, sir.
Yeah, yeah. Cool, man. Cool. So if nothing major, we can drop off. And maybe some suggestion. What is the next topic we can drive? So let's start with the InnoDB architecture kind of thing, or let's go to the replication. I think in the last session, someone suggested to uh, cover the performance tuning at the end. So, what you
You
guys,
better go for like architecture.
you mean the
Uh,
InnoDB?
yeah,
Yes,
let's
But
just
yes.
what
start
I am
with the
feeling
architecture.
is, if we start with the InnoDB architecture, then we should address the performance tuning.
No, Sri, actually, just can't you explain that complete MySQL architecture?
Okay, so better.
Actually, that is what actually just if you would have
Let's go with this
Start with that.
physical file thing tomorrow. All this explaining the.
No, yeah. At least just first give a complete overall this one MySQL DB architecture.
Hmm.
So in that actually part of that InnoDB architecture we can take it.
Hmm.
Could you first go through that one? How that the client connection, client and this one in between this one database and before the this one database structure, the complete database architecture. In that physical files are there, physical and this one redo log files like bin logs, and these are there, right?
Hmm. 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 Hmm.
Altogether, then just it will come to the this one storage engine. Storage engine is nothing but a InnoDB.
Yeah. Cool. I think let's focus on that tomorrow.
Yeah. When you are going to explain about these log files,
Yeah, so that's what I'm thinking. Before getting into this, we have different log files here, log and related
yeah.
parameters,
So
logs.
yeah, so you go to the performance tuning at the last, but before that, InnoDB architecture. Before that, complete this one MySQL database architecture. In that
Mm.
MySQL database architecture, what are the files are available?
Yeah, yeah, we will.
Okay, so how that behaves and what parameter related to that files.
Sure.
Yeah,
Yeah,
tomorrow if
let's go in
possible.
that way.
First,
Yeah, that makes sense.
yeah. So the client connections generally the how the clients connect to the database. Like by see basically that here is compared to other databases. Here there is a new concept like threads. In other databases, it will come like this one sessions and processes, right?
Mm.
Here that is different like thread
Here
concept.
also we have the session concept.
Mm. No,
We
yeah.
we have the dedicated session parameters. Everything is available in MySQL.
Mm. So here, see the process is session or process is one to one, right? That is in that threads are number of threads available.
Mm-hmm.
See, like whatever show process list which you are giving here, which it is showing, those
Mm.
are not like a process. It means not a physical connections.
Yeah,
Those all are like internal threads, right? It will split as a thread. Actual process at OS level only one, that is MySQL D.
yeah, that is
If
the
you
name.
kill
Right?
yeah, only daemon. That is the only one process. Remaining all comes under a thread concept, right?
That will establish the connection, right? That is all the TCP or local socket connections.
Mm. Those are called as a not processes. Those are all called as threads, right?
Yeah, yeah.
Yeah. Okay. So I have in that actual architecture,
Yeah,
I
I
have
got
little more
you.
questions.
Yeah, I got you. I got your
More
point. So,
questions because actually I'll compare with Oracle and then what is the major difference here, Oracle and this MySQL.
mm-hmm. Okay.
That is very one thing. And one more is
Yeah, Shri, that will be good. Like, if architecture overviews are there, then we can understand how MySQL will work in means
mm,
for buffer level and how it will work in uh, means disk level. Those kind of overview, high overview, it will easy to understand remaining sessions also, right? So
Mm.
remaining
architecture
sessions. Yeah.
first, that will be good.
Sure, man. Let's do it tomorrow.
Okay.
So, if
Yeah. Could you come with some graphical architecture, some graph or something, some figure?
Comparison, I think. Moise is asking for
Not
the comparison.
comparison,
Let
some
me
at least some GUI figure, or you can at least try to diagram with come with some diagram, right?
I'm not getting you.
No, no,
Yeah.
diagram, some
Diagram,
diagram,
right? Okay.
actually architecture
He's
diagram
asking,
Okay,
he's
okay.
asking the entire architecture in diagrammatic format.
in diagrammatic form.
Yeah, yeah, sure.
like physical files, logical files, processes,
There are
like
so many are there in this one, right?
memory structures.
Yeah, actually, if you are asking for diagram,
Yeah.
segment MySQL blog in node picture. So this is actually this diagram was written by I draw this.
Okay.
So here you can see all the flow and the related parameters also where it will involve. So
Hmm. No, something actually
yeah, yeah.
which
So
is
we can
you
go
are
through
very
the
much aware of that one. We will continue the same thing. We will follow in our future in
yeah, yeah.
future
We
This
can
also.
go through the MySQL.
general architecture, Sri,
Hmm.
general architecture.
Yeah, yeah, yeah.
They are
We can
asking the
go.
general architecture, like
See, actually, there are two things. One is the logical architecture and the InnoDB architecture. Okay.
mm,
Hmm.
so they
So
are asking
we'll go
logical.
through both of them.
Logical architecture.
Yeah, for the InnoDB architecture, we can go use this one. This is from the MySQL official documentation. And for the
Okay.
logical architecture, I need to find one. Otherwise, let me create one. I will see that. Okay.
Yeah.
And
First,
we'll,
if we understand that logical architecture, then in that part is InnoDB, right?
yeah, yeah, correct.
Yeah. So first, just yeah, whatever you are familiar with that logical architecture to
Mm.
explain us.
Correct.
So actually,
Sure, man. We will do this tomorrow.
mm.
So, if there is any question, otherwise we can
Shakti,
drop off. Yeah.
related to timings, like my office weekly, I need to go for 3 days. So now it is Tuesday to Friday. So, so just wanted to check, like in including 2 days in weekdays and 2 days weekend, it will be better for me. Or else, because I will start by 6:30 to go to office. So I'm unable to session because I will be traveling in that time, and I don't know how the internet connectivity will be in traveling. So just my request to you, like include it, like start from Thursday to Sunday, whatever the side timings is.
Weekend, I don't want
No,
to.
weekends, some people will not be interested, right?
Yeah, we can
No,
plan for some weekend sessions, but not now, later.
no,
Uh,
this month is fine. I'm working from home. I'm doing, but January onwards, I'm telling.
sure, need to get the consent from all the teammates.
Yeah,
Let's see how we can
it's
check in
because
the group. Okay.
yeah, else I will miss the sessions, like live sessions. I need to go through recordings only, but live session will be better.
Yeah, yeah, I
You
can
just cross check.
understand it.
Yeah.
But yeah, we need to think.
After class, you can go to office, right?
No, no, like I will use office cabs, so it is far away from my distance. If I go, my login time is 8:30, 8:30 to 5:30. That is the problem.
Hmm. Let's see, Vishwanath.
Mhm.
Let's see. Okay. We'll check in the group. Let's see how we can. Maybe changing the time. Weekend is something really I am not taking now. We may have some weekend session, but later at the end.
See, if you go like this way, everyone have their own concerns, so it will come
Yeah,
everyone's concerns. So then it will be prolonged and totally it will disturb.
I
that
don't
is.
want to disturb it, but my situation is like that. So instead of it is working, it is well, or else I have to manage. It is
Yeah, right.
we
You
are
know,
planning for
night like
Tuesday to Friday, right? Instead of that, I thought Thursday, Friday, Saturday, Sunday, or else including 2 days, um, Saturday, Sunday, Monday, Tuesday, like that. If it works,
no man. Weekends, at least revision should be there, right? At least we will revise the things weekends. Like I'm not interested for weekend.
Shakti, you check the better way and let us know.
Yeah, yeah, we can discuss in the group. Yeah.
Okay, thank
This
you.
this month is okay, right, for you?
This month is fine. Yeah, next
Yeah.
month I'm thinking.
We'll see,
Just
man.
why I raise this concern instead of raising this cursor at the month end. So in mid of I just
Okay, sure. Yeah. Cool, man. Yeah,
okay.
let's see about that. Okay.
Thank you all.
Cool. Yeah. Bye. Thank you.